Okay, so in this session, we'll be discussing about the buck converter. It's an open loop. Open loop means actually we can't control the output. So desired output we can't accept, or you can say desired output we can't manipulate the output. That is the meaning of the open loop converter. That means based upon my input and the output, I have to tune the values of the R, L, and C. So it's very normal modeling only. If you go on a Google and type the buck converter circuit, you will be getting that. Okay. So maybe in the other session we'll be discussing about the converter in the closed loop also. So it's a diode. Okay. Just see the position: inductor, capacitor, resistance. It's a IGBT diode. It's a pure diode, and the DC voltage source that I am taking is actually uh, 20 volt. So the output what I am expecting, based upon that I have to tune the values of R, L, and C. And even you search on outsource the formula for the buck converter, you will be getting the formula. Okay, so the intention here is to make you understand about the meaning of the pulse generator. Okay, pulse generator will generate the pulses like this. Okay, and depending upon the values of pulse generator also, my voltage will vary. So right now I keep the pulse generator values as 60%. So for 60% time switch is on and 40% switch is off. What is the period? 2 to the power minus 5. So if you take reciprocal of 1 by 2 to the power minus 5, that means I am taking reciprocal. So I'll be getting frequency. So 2 e to the power 5. Okay, that means 2 into 10 to the power 5. So 1, 2, 3, 4, 5. Okay, so you can understand what is the frequency. So 2, this 3 will count for kilo. So 200 kilohertz is the frequency. Okay, so in this way you can give the frequency to the power electronics switches. Okay, pulse width is 60%. Okay, that means for 60% of the time my pulse is on, 40% my pulses are off. Okay, maybe in the some video I'll be discussing about how to generate the pulses. This is a direct pulse. Okay, that means we are giving the pulses directly to the gate terminal of the switches. We are not generating pulses manually. We have a data of the pulse generator, okay, and that we are giving it directly. We can also generate this pulse with the help of the intersection of the two way that I will discuss in one session. Okay, so DC voltage source is set 20 volt. Okay, based upon my values of R, L, and C, I will be getting the buck output. Buck means the voltage will step down. It's a DC-DC buck converter. So voltage is to step down. So run here, okay, and you can see the voltage will getting step down. Okay, it is running. It is will compile. It will take some time. Okay, and just wait for a minute. Okay, let the model compile, and you will be getting the step down output here in the display. Okay, so my output as I'm getting is a maybe it will take some time to settle down. So you can see it around 11.68. Okay, it's my output. So I step down my I think 20 volt to 11.68 with the help of the buck converter. So for that purpose, you have to tune the value of RLC. Not tune, I have to say that you have to set the values of RLC. Okay, right. So this is the buck converter open loop. Why open loop? Because I am not taking any feedback from the output. In one session, we'll be discussing about the closed loop also. When you take the output from the, I mean to say feedback from the output, and do some comparator type of, or comparison type of scenario, it's called as a closed loop system. Okay, so stay tuned for the next video.